Welcome to a special season of Seen from Above, where we ask an important question, namely, is the future of geospatial in the cloud? We'll be hosting a series of conversations with guests whose experiences and careers give them special insight into this topic.
With an ever-increasing amount of satellite data and computational power available, moving geospatial workflows to the cloud opens the doors to powerful insights. But what does it really take to switch to doing things in a cloud-native way? Let's find out together.
I'm Julia Wagemann.
And I'm Sabrina Zito.
And together we are co-founders of Thrive Geo, a training and consulting company whose mission is to empower businesses and organizations to use geospatial and Earth observation data.
Through this season, we hope that as a geospatial professional or as someone interested in Earth observation data, you'll get to know more about what the move to the cloud means for our industry and for your careers. Thanks for joining us. In our first episode, Julia speaks with Jed Sundwall, the Executive Director of Radiant Earth. He has been instrumental in bringing open geospatial data to the cloud. Under Radiant Earth, Jed recently started two initiatives, CNG, the Cloud Native Geospatial Forum, and the Source Cooperative. In this episode, we learn more from him about what cloud-native geospatial means and where he sees our industry heading.
Jed, hi, welcome to the podcast.
Thank you. Yeah, thanks for having me. This is great.
So, Jed, you are one of the pioneers bringing satellite data to the cloud. So, in your own words, what is the geospatial cloud and why do we need it?
I would say, I don't typically use the term geospatial cloud. I tend to just refer to the cloud, and it's actually it's not a great term because it's. I hate to say this, like it's nebulous, because nebulous is a word, that has the same etymology as cloud. It's cloudy. It's hard to define. I actually just very recently came across a way to think about the cloud, which is that it's computing beyond the capacity of a single device, where we now have access to you can instantiate or turn on computers that you can access and interact with over the internet. You can store all sorts of data in cloud servers over the internet and access them whenever you want. And what this does is give us, access to just tons and tons of distributed computing and storage capacity that allows us to transcend whatever, limitations we have locally on our computers. So that's broadly what the cloud is. It's just distributed computing that is increasingly easier to access. And as we get more and more geospatial data into this distributed computing environment, whether it's, and for the most part, this is usually going to be through commercial cloud service providers like, Google, Microsoft, and Amazon, and T-Systems, I should say, Alibaba Cloud. I know there are others that aren't the big three American ones. But as we get more geospatial data into these distributed computing paradigms, we have to think differently about like how we interact with that data. And so there's a broad movement, I would say, within the geospatial community of like figuring this out. So I don't know if that's a good answer or not, but
no, sure. So you said so the main benefit is that we have now more processing capacity. We can put on satellite data or the data we bring to the cloud. Is there any other benefits you see for the Earth observation industry?
Well, no, I'm actually kind of like less, the processing capacity is a huge part of it, obviously, but like, it's really more about the data storage and access. So, sort of a better way to understand it, and going back to the kind of like, compute beyond the capacity of a single device, which for what I should give credit, that's Tim O'Reilly who said that a long time ago. It's the storage capacity. It's the access to data. So I worked at AWS for 8 years doing open data stuff and doing a lot of sustainability stuff. And very early on, we received a grant application from some researchers, I think at the University of Virginia. And they applied to get credits to use AWS for free for their research purposes. And they're like, we need, I forget what it was, like hundreds of thousands of dollars, just so that they could store a few hundred terabytes of Landsat data themselves, And I was like, okay, this is interesting. they're asking they're asking for storage for data that's already free. But they needed hundreds of thousands of dollars just to store it. And their mentality was like, for us to analyze this data, the first thing we have to do is acquire hundreds of terabytes of data, which means hundreds of terabytes of storage, and the bandwidth costs and just the time just to transfer that kind of data. And the impact of that is like that mentality very much limits research, because what ends up happening is that researchers, they limit themselves to ask questions based on whatever data they have access to. And so when data is made available in a cloud environment more openly and is optimized for streaming over the internet or usage via distributed computing systems, it takes that data acquisition step off the table and allows people to move much more quickly. And so we already right now live in this situation where there are petabytes of satellite imagery and other earth science data available just on the internet that people can interact with very efficiently in cloud native ways. And that, I think that's really unlocked a lot of research and allowed people to ask questions that are, before that were just asking the question was like expensive.
Yeah. Well, and you just didn't even dare to ask that questions because you knew it's over any limits. You said, well, because we have now already. Would you actually say cloud computing is still a trend in the Earth observation industry?
I mean, this is going to sound like I don't work for Amazon anymore, but so I kind of hate to sound like I'm a shilling for them or giving cloud talking points, but to me, it does feel like it's the new normal. You can't escape the cloud. You can't escape, slinging data over the internet. And if you want to work with data at any kind of, significant volume, you're likely going to be dealing with data that's stored in a cloud somewhere. Despite that, local compute just keeps getting better and more powerful. I think, these new generations of ARM-based processors are really intriguing and fast. I have the cheapest MacBook, the M1. It's incredible. It's very performant, and they just keep getting better. So there is a trend, coming about now, sort of back towards, making sure that people are really taking full advantage of what you can get done on a single device. I don't know enough about it to explain why it's such a big deal, but everyone is talking about DuckDB these days. That I think you can run on a single device locally and interact with very large volumes of data that are stored remotely or locally very, very efficiently. And so that kind of showcases how what I was saying before, actually, how the compute capacity of the cloud, where the idea that anyone can spin up a cluster of hundreds or thousands of cores or something like that to do very large scale compute. Most people don't have that use case. That's way too complicated for most people. And I think there's a lot to be excited about this sort of, I don't even want to say hybrid approach, but it's kind of a hybrid approach where you are running your compute locally, but you're interacting with volumes of data that are stored remotely in a cloud somewhere. And you can get a lot done that way. So.
Yeah. So what do you think, with your experience working at Amazon in the past years, who is actually using the cloud? Is everyone already using the cloud?
I mean, the cloud, this was always an interesting thing for me when I worked at Amazon. I'd have to explain what the cloud is to people. And I'm like, you're using the cloud right now. If you use Netflix, you use the cloud. If you use Dropbox, you use the cloud. And so, and anyone who's interacting with data and, applications in their browser and things like that, for the most part, these days are they're interacting with something that we would consider cloud. There's plenty of systems out there that are I would say old school. It's your university's data center running an email server. That's not cloud. But so many services that we interact with are cloud services. The people who are actually in the AWS console or something like that are still far and few between. It's I would say all the commercial service provider clouds, whether it's Google Cloud Platform or Azure or AWS, they are power tools. Most people aren't interacting with them. I think a lot of people who are using the cloud, they might be using ArcGIS Online, which is a cloud hosted service. Or they might be using any other kind of like Felt, for example, is a great new mapping service. Like that's a cloud-based service. So there are a lot of ways that people are interacting with geospatial data, benefiting from cloud native approaches or benefiting from the cloud without really having to think about like, they're not saying to themselves like, I'm using the cloud right now. That's not, not a mentality you have to be in. So I don't know if that's an answer to your question. I'd say like, it's kind of like everybody, but also like if you're really using the cloud, it's not that many people.
Yeah, with many use the cloud without realizing it, because also many software applications they already use in the backend cloud, but it's not necessarily directly to the users in engaging with the cloud compute. Okay, so I like to. So thanks for giving this really nice introduction on the topic of today. I'd like to take a step back. As I said, I introduced you. Like as one of the pioneers bringing satellite data to the cloud. And so what is your story? How did you end up bringing satellite data to the cloud?
Yeah. I like I would say many geospatial people, there are a lot of us who just kind of accidentally got into this world. My background is very much in the humanities. So I studied literature and then I studied foreign policy, and I've always been obsessed with the internet and a huge fan of the internet. And so when I got my master's in foreign policy, I decided I wanted to work for startups and do like internet stuff. And so that's what I did at the beginning of my career. And the long story short is that I ended up in 2014 joining AWS to build the open data program there, because I had just a lot of experience at the intersection of like the internet and policy, and was very interested in open data and open data policies through my background. And so it was a very good fit for me, and great team, very supportive. And I, through all my interest in open data stuff, had become friends with Chris Holmes, and he was like, hey, you should put Landsat on AWS. And I was like, I don't know what you're talking about. Like, I didn't know what that was. Like, I know he worked for Planet. Like, I knew about satellite imagery, but I didn't know that much about Landsat. And so that was really what started it all. Was, I trusted him, and I just started looking into Landsat and figuring out what I could do. And turns out, he was right. Like, Landsat was this, like the story I told before, these researchers who they were applying for grants from us just so they could work with Landsat data. It was this very valuable asset that everyone recognized as being super powerful, but was just too hard to get at scale. And that's when it dawned on me that like this was really the sweet spot for AWS, especially like building an open data program, was that like we had the capacity to host data in ways that no one else could. When I started, there was a bit of a false start where we were like, oh, should we be like hosting data portals in the cloud so that people can come download, your city's municipal data, like open data site in the cloud? And I was like, that's just not that interesting. Like, you can run a little city's data portal on a single server. Like, you don't need the cloud for that. But with these large environmental data sets, I was like, no, this makes sense. Like, this is something where I think we can have a big impact. And then, so yeah, we started in 2015 is when we announced it. Also, shout out to Amazon. Like, you can have a lot of opinions about the company. I definitely do. But like, for an English major to come in and within a year, they're like, yeah, you can host a petabyte of data. Like I got approval to host up to a petabyte of Landsat data. And that was the beginning of, what the open data program at AWS is now. And they've publicly said, they host over 100 petabytes of data now across, it's not just satellite data, it's genomic data, like, massive corpuses of text. There's a data set called Common Crawl that's like the basis of all large language models. That's all hosted in that program. So anyhow, but the Landsat thing, it was just such like a wild success that I have been unable to escape the geospatial community ever since. I love this community, so it's been great.
And hopefully you also don't want to escape.
No, I don't want to escape. I don't want to escape. Yeah.
I think just this happens to many, right? Like, it's a really nice, enjoyable crowd. So on your website, you were saying that you accidentally created a data format that is now, one of the data formats that can run on the cloud, a cloud native geotiff. Is this also part of when you brought Landsat to the Open Data Registry?
That's right. Yeah. So that was when I started digging into Landsat and sort of like, I did a lot of research and talked to tons of users about like who uses it, what they're using it for, how they get it, etc. And what I found at the time, the normal way of getting Landsat data was you would go to, I forget what it was called. It might be Earth Search. There's so many, all these things, they all have like similar names. But it was like a USGS site where you would kind of fill up a shopping cart of Landsat scenes that you wanted, and then you would download them. And they would come in roughly a gigabyte size tar archives. And I talked to all these people and I was like, do you use all the data you get? And they're like, no, of course not. Like we throw 70% of it away, like immediately. Like you'd get the 12 bands of data. Most people would use 3, maybe 4 bands. There's one guy, he's like, oh no, I use all of them. And I didn't believe him. He's like the one outlier who said he used everything. And I was like, all right, well, this is silly. I by that time I'd had experience working at like Web 2.0 companies and building APIs and things like that. And I was like, you don't move data over the wire if the user doesn't need it. Like that's just like basic. It does not make sense to do that. So I was like, I'm not doing that. I'm going to host the individual TIFFs in S3. We'll name them in such a way that people can programmatically find the TIFF that they want. So it's like, I want this scene. I only want the infrared light or the near infrared, whatever the band is. And you could just get that TIFF. That was my like major innovation, was just like unpacking the tarballs. And tons of people were like, you can't do that. The people's pipelines expect the tarballs, and this is going to break their pipelines. And I was like, I hear you, but this does not make sense to me. Like I was very naive. I was just like, I can't. Like in good consciousness, I can't do that. So in good conscience, I couldn't do that. And then I was working also with Peter Becker from Esri and Frank Warmerdam at Planet on this. And I'm at Capadia, also at Planet. We're all involved. But it was I give Peter Becker most of the credit here. He was like, you have to do internal tiling on the TIFFs. And I was like, I do not know what you're talking about. Like, I don't know what that is. And he was very patient and generous with me. And he's like, look, here's what's going on. You can rearrange the pixels in the TIFFs so that rather than downloading them like row by row, which is the way you normally get a TIFF, which I've since learned, a TIFF, like its origins go back to like fax machines. It was very much like the idea is that you're sending an image to a printer that's going to print row by row. And that's how, TIFFs are normally transferred. He's like, no, you can change it so that as the data comes in, it will give you a tile, and then it'll give you the next tile, and then the next tile. And if you do that, it allows people to only fetch a little bit of data that they need, and then also add overviews so that people can sort of easily preview the imagery. And I trusted him on this, and so that's what we ended up doing. We documented it, how it was done, and it was but again, it was like very presumptuous. It was not like, I didn't expect this to be like a file format. My only mentality was like, we should make this easier to access. Like it should just be much faster for people to access. And it worked really well. Like we hosted enough data, at the time it was only Landsat 8 data, but we had enough of it, and it was so easy for people. And we launched with like demos of like what you could do with it, that people are like, oh, this makes a lot of sense. And I also want to emphasize here is that like that concept of like internal tiling and overviews, like that was a pattern that lots of people used, but no one had ever made data available in that way on a cloud before. And then Chris Holmes comes back in, where he took this and ran with it and was like, we need to make this a thing, and gave it the name, the Cloud Optimized GeoTIFF, and really evangelized it and got more people to adopt it as a format. But it was just never, I had no idea. There was not, there's no intention to be like, this is going to be the new format that people should use.
Yeah. So when was that around? Like at what time?
It was 2015. I remember it like pretty clearly. It's weird. Like this doesn't happen that often. It hasn't happened that often in my life, but like we put a ton of work into that, into getting, it was like the first big thing that I did when I was at AWS. I did all that research, lined up all these demos. Like Mapbox did cool stuff. Esri did MATLAB. I'm leaving other people out. Oh, Development Seed had built a thing. So we launched with like all these demos. In like the day that we like posted the blog post, like announcing it and everything was up, like I got chills. Like I was like, I think this is a big deal. I had like sort of a premonition that like it was going to be a big deal, but I did not. Whatever. It's like still exceeded whatever thoughts I had of like what a big deal it was.
Yeah. Do you think, because there is like now also a new term that has been evolving the past few years, cloud native geospatial. Do you think this was the beginning of this new type of concept?
Yeah, I mean, I would say so. Like this is, that's got to be where it started. I mean, the other thing that we did at that time was also the precursor to Stack, because USGS would provide these little text files with metadata for each scene. And we created a Lambda function, which, if you know what AWS is, just like a tiny, very tiny container that basically we said, at any time a new scene arrives, look for this text file and turn it into JSON. And so we train people to know, like, there are these little JSON files adjacent to the TIFFs that have the metadata that you can programmatically look through. And I think that was kind of that pattern evolved into Stack, this idea of like having little metadata here and there in these object stores, like in something like S3, became a pattern. And so, yeah, I think those two things combined have led to what we now call cloud native geospatial. But again, Chris Holmes, I think, gets a lot of the credit for like making these creating these names, like cloud optimized and cloud native geo. Like he's really been like the evangelist for this terminology. And so anyway, he's been a close partner for a long time. I always want to give him credit.
Can you describe in your own words, in a few sentences, for someone who doesn't know anything about this concept, what cloud native geospatial means or is?
Well, I'll send you, there's a GitHub discussion that I tried to start last year or sometime in this past year where I'm like, what does cloud native geospatial mean? Because Peter Becker, also at Esri, is kind of giving me a hard time about this. He's like, what is it? In my mind, it mostly refers to working with geospatial data over HTTP and like, in a distributed computing environment. So meaning you're interacting with data that's being transferred over the web. And in most cases, it's likely hosted in the cloud. You may or may not be turning on your own servers in the cloud to interact with it. But you're like efficiently working with data that's been optimized to be transferred over the internet. And you might notice there are like, I'm not crazy about the term cloud native, because I think it does mislead some people into thinking like they have to use the cloud to benefit from it, or that most of the computing has to be done in the cloud. The cloud is obviously an important part of this, but for most people, I don't think they have to worry about, again, like I said before, they are probably rightfully intimidated by using logging into a cloud console and they don't have to benefit from this. So if I could rewrite history, I might call it like web native or something like that. But cloud native is kind of what's taken root within the community. And we've been using it for enough years that like I'm okay with it. But so that's an answer with a lot of caveats. I hope you don't mind.
No. So what is part of the concept cloud native geospatial? You were mentioning, so we talked about cloud optimized geotiffs, so like data formats. You also talked about Stack. So is there kind of like a recipe where you say, okay, like you have to put specific approaches together to have the cloud native geospatial approach?
I wouldn't say so. I mean, there are, so there's some people who say like only like truly cloud native file formats, for example, should allow you to interact with them without having an intermediary server, like doing any work in between. And that's actually kind of a good way to think about it, meaning like you should be able to either, using in a notebook or something that you're running locally, or like in some like browser-based tool, interact with data that's hosted somewhere else. basically in real time, very, very efficiently, without having to transfer an entire file over. Like that's a way to, without, and without having a server in between mediating that exchange of data. Like that's a bit more technical definition, but again, I mean, I'll send you this discussion where we kind of like never really came to a conclusion, because it is very hard to define like what is and what is not cloud native. I'll go back to like where I sort of tend towards is like, if you can work with the data efficiently over HTTP, like if it's fast and you don't have to download a ton of data before you work with it, then you're probably doing something that's cloud native.
Okay.
Yeah. And actually I'll just like reiterate again, the big difference here is moving from a paradigm in which like, for you to get started on your work, it used to be that you had to download a bunch of data locally before you could do anything. That's no longer the case. You don't have to download, like you can interact with data that's hosted somewhere else quite rapidly and efficiently. That's a cloud native approach.
Okay, so if we have now a look on these various different cloud offerings that exist. So we talked about commercial cloud providers, Amazon and Google, but then we also have more these geospatial cloud platforms. One of the earliest one was Google, or is Google Earth Engine. In a few few years, we have from Microsoft the planetary computer. Are they all cloud native geospatial?
So some people might, like, I hope I don't like ruffle too many feathers here. Like Google Earth Engine is clearly like a cloud hosted thing. But it was created like long before any of these concepts of, or like, before the cloud native GeoTIFF, or sorry, cloud optimized GeoTIFF came about, or any of these movements towards these like efficient ways of slinging data over HTTP. I would care, and also I'm out of date on this, so I don't like. I know that there's been some activity moving Google Earth Engine to Google Cloud Platform and making it like cloudier. But I think previously it was just like a very, very powerful software as a service application that was run on Google servers. And it's extremely sophisticated, obviously very powerful and very widely used platform. So like, I'm not like, this should not come across as a knock, but like, it was not built on what I would call cloud native principles, even though I haven't really very well defined what those cloud native principles are. It's just a much more like complex software application with a lot of servers running custom software to do what it does. The planetary computers would be kind of like, I love the story of the planetary computer, because like I feel like that team really showed us up at AWS. Like we'd been hosting all this data on AWS and satellite data, and then my friends who go over to Microsoft and they're like, we're gonna do better than what you've done, and they did, which was to say like, we're gonna take what you did at AWS, which was like, all we did was just put content into S3, into the object store, and say, we've optimized this for being served up over S3. It's very efficient. It's very performant. If you know what you're doing, you can do amazing things with it, and people did. I think probably the most visible and like obviously successful application built on that was Sentinel Hub from Synergize. Like phenomenal work. But like lots of people built amazing things with it. But you really had to know, there's a lot of like startup work you had to do to do anything. Microsoft was like, okay, we're actually going to help you out here and like, have a hub so you can run notebooks, that are ready to go on top of this data, and like do the extra work to make sure that like there's good metadata, stack catalogs and things like that. I can go into the details if you want, but like at AWS, AWS didn't really do much at all with the data itself. It relied upon data providers to do that work. And sometimes they would provide good metadata and stack catalogs, and sometimes they wouldn't. Microsoft, they invested, extra time and effort and had staff to make sure that there was good metadata there, and that there was a compute environment like ready to go that people could work with. But all based on open source software, so that if you didn't want to use their compute hub or whatever the servers that they were running to run the notebook, or anything like that. You could do it yourself and, and scale it up as much as you wanted. And so anyhow, so like, I would say, Google Earth Engine, huge inspiration, obviously like showed everybody like what's possible with cloud capacity. What we did at AWS was like very much, I would say more like proof of concept-y, largely because like I couldn't hire engineers. I won't go into the details, but like, it's just like I was in a part of the organization that like wasn't even an option to like hire a team to like build something like that. And then Microsoft, I think, showed us up with the planetary computer, which I'm very happy about. Like, I think it's great.
Yes, yes. So if we have like a look on these different options, I would say probably because it targets slightly different type of users. As you already said, like Google Earth Engine or Planetary Computer, it was much more accessible for, I would say, any practitioner. You could start a Jupyter notebook and then you can do the analysis. Whereas the Open Data Registry, you need probably more technical knowledge into how things work on the cloud, and could probably also hinder many people to use it, because there's like it requires a new set of skills and understanding of how different processes work.
That's right. But I mean, I would say like I sort of defend that approach, because doing that allowed us to be extremely lean within the organization, which allows us to survive, right? Like we were always running, and I think that team, I mean, I'm still friends with all of them, continues to be a very lean team, not a ton of resources, which means like you can survive business cycles and stuff like that. And so it's been a way to create like sort of a very durable approach from a corporate standpoint, and shift a lot of the risk of building and creating viable services out to the market and the builders who can build on top of it. And that's played out decently well. I think there's a lot of vulnerabilities in that approach. But one thing that was very important to me was that I didn't want to suck any oxygen out of the atmosphere for builders in the geospatial community. I don't like it, and I won't name names, but I think it'll be like kind of obvious like what I'm talking about here. Like I don't like when big tech companies say, "Hey world, we solved all of your problems for you. Like you don't need to do anything because we've solved it." I'm much more interested in figuring out how can we use technology to empower more people to solve their own problems and build new things, because the potential of geospatial data, and really kind of any data, is so vast. I get a little bit worried when one solution kind of dominates, that people are like, "Oh, this is the way that we're supposed to work with this data. This is the best way to do it." And I'm like, no, I mean, that's what's one way. And so one thing that I really like about the cloud broadly and computing broadly is that it allows people to be so creative. And so I feel like this people might think I'm like copping out because I couldn't like hire engineers, but like I actually believe this. Like doing a sort of like not maybe not the bare minimum, but like finding that sweet spot of like, look, we've taken a lot of annoying work off your plate so that you can do more stuff with this data, and then getting out of their way, I think, is a cool thing to do. Like I'm really happy that we did the way we did.
Yeah. So we have, like you said, like you started in 2014, Google Earth Engine started around 2012. So we actually already have cloud solutions for the past 10 years in the Earth observation industry. And yet I would say the reality is still that we have like so much data being downloaded, and probably many Earth observation professionals spend 80% of their time downloading, harmonizing, converting data.
Yeah.
Why do you think that is?
I think there's just a lot of I never know if I was supposed to say like inertia or momentum. I mean, like there's still like momentum behind like traditional software models, that just keeps moving. But then there's inertia. People just don't like to change what they've learned. We still have universities and schools all over the world training people on like a desktop based approach, like a local computing based approach, because that's what the professors learned. And that's, it just like that mode of compute is just fully entrenched, I think, in like a lot of people's in a lot of educational systems. And so, and also, I mean, it's just the way that we still live our lives. Most of, I don't know, like maybe I'm not a normal compute user or something like that, but like, it's just very normal for people to like download files, have them locally, have your local file system, know where your files are, open them in applications. Like that's just like a very normal way of computing still. And so I think we still have a ton of work to do to educate more people on like how to do it a different way and give people the tools. The other issue that I'll say, and this is where like I'll kind of like admonish my community a little bit, is that like the geospatial community, like the cloud native geospatial community, awesome people. Obviously, I love them. They're my friends. But like it's a lot of like super smart, extremely talented people making tools for them and their friends, you know. And you know, we were talking about Max Lenormand before we started recording, but like he was on, you know, I've been on his podcast, he's been on my podcast. When he was on my podcast, we were talking about GDAL and like how amazing GDAL is, and like everyone, like so many careers are built on GDAL, but like it is not like a friendly thing for mere mortals to learn, you know, when they're coming in to this community. So I think there's a lot of work that we need to do to empower more people and to help create on-ramps for people to understand how to benefit from these things. And if you'll, you know, indulge me, like, I mean, like that's why we at Radiant, you know, we've recently re-announced or rebranded our Cloud Native Geospatial work to the Cloud Native Geo Forum, because that's what we're trying to do, is just create a space for geospatial data users to interact with each other and learn from one another, but explicitly with the goal of being like, we need to bring more new people into this community. We need to figure out like how to bring new people in. Because if we say like, hey, one cool thing that you should learn if you're using cloud native geo stuff is GDAL, good luck. You know, I think we're going to lose a lot of people before they even get started.
Okay, so you mentioned that like as part of Radiant Earth, you started Cloud Native Geospatial Forum. Mm-hmm. So, and you said already like, okay, you want to kind of build up a community, but like, let's say, who is the Cloud Native Geospatial Forum for? Is this for anyone who already understands cloud native, or like any individual who might be interested in getting started finally into starting a new approach and processing the data? Or who do you want to have?
Yeah. So the community is for geospatial data users. That's how we describe it. It's like, if it's your job to actually work with geospatial data, like we want you in the forum. Like we'd love to, you know, support you. And that community includes people who, you know, the people who like created Stack, or the people who, you know, are creating open source tools that you can use to, you know, to create Stack catalogs, interact with them, or, you know, work with GeoParquet data or whatever it is. It has those people, but also just has like, you know, again, the mere mortals, the people who like, it's just their job to figure out, how do I work with this much data that I now suddenly find myself having to work with, and I don't know where to get started. And one of the things that motivated us to do this and to take this approach was that like we kept finding that really like great things would happen if you got people who had, let's say, startup experience or big tech company experience talking to people with, you know, working in government or working in academia, because they all use the same data. Like they're all, you know, we can just continue to use Landsat as the example. But there's so many other data sets you can imagine, like OpenStreetMap or Overture data. All these people, they're all working with the same data, but they have completely different like agendas and objectives and like skills available to them. And whenever we can bring people together from those different worlds, good things happen. I've just been, you know, I think there's kind of a lack of spaces like that for geospatial data users to have just sort of like candid conversations with one another about what works and what doesn't work. You know, there are other conferences that are like explicitly about like one software platform, or the conference is about, we don't like that one software platform, you know, or you go to reInvent, which is, you know, AWS's thing, and you're just going to hear nothing about nothing but AWS stuff the whole time. And Google Next is the same thing. And like, I think we needed a vendor neutral place where people could just have these conversations.
Yeah, yeah. Do you also see the Cloud Native Geospatial Forum as like kind of like how do you say, like a community where the community also defines the best practices in this space? Because I think the challenge in taking up cloud native or the new formats is often also that the information is spread around every day. It's like on LinkedIn, on GitHub, on the internet, on YouTube. Right. But then if you start, then you often, okay, is this the right way how I do it? And it's always this insecurity where I think this guidance of best practice, which gives you also then confidence and, okay, this is the way how it is done.
Yeah. This question is really provocative for me because like, I want to emphasize short answer is like, yes, but also we have no interest in being a standards organization. Like OGC is serving our community perfectly well, like with setting standards and defining those standards. Some customers or some organizations really need to have standards, and they need to know that they're following some sort of standard practice. Governments, most obviously, like, often behave this way. And that's great. So OGC is great for that. We don't want to supplant that. I'm very proud of the fact that like the COG, the Cloud Optimized GeoTIFF, is a OGC community standard now, as is Stack. Like, so I do think that we will likely identify new patterns and best practices that mature or graduate into becoming full standards at some point, and that's fine. But back to the question. So the short answer is sort of yes. We want to have a forum or a space where people can show each other what works, like practically what actually works. But I would stop short of saying like, we're never going to say like, this is how you should do it. Like, because what I think we can predict quite confidently is that some random person is going to show up someday with like a new approach. We're like, oh wow, we didn't think about that. Like, that's not something that would have been considered best practice, until we saw it. And it turns out like you found something like really exciting and new that works really well. So yeah, it's something that like I have thought about potentially, like, could the forum provide trainings and kind of like some degree of like credentialing of like, hey, like, you've learned the basics of cloud native geo, like, about GeoParquet and cogs and stacks, and how to create them and interact with them. That we could maybe go that far, but like, I don't want to get into the business of like endorsing or blessing certain approaches as being like the right way or not, because I want our community to continue to find better ways of doing stuff. And I worry about us getting sort of like fixated on like what we think is right.
Yeah. So if someone who hasn't started using the cloud, but they would like really interested and keen on starting on the cloud native geospatial, what advice would you give them? What is the best way to get started?
I mean, I would say like there are people within our community, like Qiusheng Wu and Matt Forrest are both just sort of like relentlessly producing great content, and like tutorials and training materials and stuff like that. I mean, this is not a rehearsed answer at all. Like, both of them come to mind as people who are sort of relentlessly putting out really good content and educational content to like help people get started. It's so hard to say because, I mean, I think as like there's so many routes into geospatial. There's so many ways to approach these. You might be interested in vector data. You might be interested in mapping. You might be interested in processing satellite data. It's really hard to tell people where to start. But the good news is, I mean, there's constantly new stuff coming out. I should also say though, I mean, this is like, I'm a terrible executive director of an organization that like the first answer I should have given is like, go to cloudnativegeo.org and sign up for the newsletter. We also have a blog you can subscribe to. But you can follow us on LinkedIn. Like, we have a new discourse forum where there's not a lot of activity in there yet, but we're also hoping that that'll be a place that people stumble into, hopefully by searching for like, how do I use Stack, and they find a discussion in there that's useful for them. So the answer is like, right now there are a lot of places to get started, but we recognize it as something that we need to improve. The answer to that question should not be as long as this answer was.
Yes. Okay. All right. So now, because I'd like to just have my last question on a perspective more looking ahead. So
Sure.
if we look ahead 10 years down the road, is the future of geospatial in the cloud?
Oh yeah, for sure. Like I mean, I've bet the farm on that. Like, again, going back to my like initial definition here of like, it's compute beyond the capacity of a single device. I think we can look forward to a future in which there, more sensors are everywhere producing data. There's more connectivity everywhere transferring that data. Yeah, compute is going to become more ubiquitous, and by necessity, it's going to be distributed. And so, working with data in the cloud paradigm is not going away. If you define it the way that I have, which is that it's more about compute beyond like your local capacity. Will the major commercial cloud providers remain dominant? I would also say probably. Like I would bet on that. I'd bet like $50, something like that. But it's not like I don't see them going anywhere as being like sort of a major center of infrastructure, or like some organizations that we rely on for infrastructure. And if I can expound on this a little bit, there's an insight that I got from a friend, a guy named Alex Polvey, recently, who he's really been very supportive of the cloud native community, who we had this insight that like maps and the way that we've like traditionally thought about geospatial data is like, oh, we need to put this on a map, right? And when you put data on a map, you're abstracting reality, you're downsampling it into something that's like, okay, it's a map. Like I've put it on this 2D thing that I can look at, maybe on a screen. And computers are cool now. Like you can zoom into maps, so you can have these like extremely high resolution, like very rich interactive maps, and that's great. But I think what the future holds in the next 10 years is so much more data that we're at this very exciting time where what we can do with computers is like actually like upsample reality, or we can create interfaces for us to see more data than we could ever like imagine just plotting on a 2D map. And so that's not going to be possible without the more ubiquitous compute and sensors producing stuff everywhere. So I'm very optimistic and excited about the future, and I think I tend to not get like excited about new whiz bang technology. But I think it's inevitable that like machine learning at scale is going to also increasingly like sort of like help us get more data, or sort of more insights out of all this geospatial data that's like too big to even comprehend putting on a map. So I'm optimistic.
Yeah, no, definitely. I think this is something where we will be super surprised what actually comes out of the data, which we can't even imagine or think of at the moment, because it's so big, especially if you apply it in also machine learning. And so we have all the different recipe parts together. Now we just have to bring also mix it together as part of the recipe.
Yeah. And we need more people to do that. I think that's why it's like, I think it's so important that we grow our community. Like we need more people doing this.
Yes. Yeah. Okay, good. So thank you, Jed, today for your time and also your insights. It was really great to have you on the podcast today.
Oh, it's really my pleasure. Thanks for having me.
And now we ask you, is your geospatial future in the cloud? Familiarity with cloud computing platforms and handling geospatial data in the cloud is an emerging skill for geospatial and Earth observation professionals. Acquiring relevant cloud skills will help you stay at the forefront of the industry. ThriveGeo has developed a course on cloud-native geospatial. Designed for those starting their geospatial cloud journey, this course will give you a practical introduction to key parts of the cloud-native geospatial technology stack. Visit our website at www.thrivegeo.com and start your geospatial cloud journey today.